Hi everyone. In this video, you will review the basics of functions. Let's start with an exercise. Match the given cities to the countries they are in. If you would like to try this exercise on your own first, you can download these notes using the link in the video description. I believe that Paris is in France, Tokyo is in Japan, Toronto is in Canada, Montreal is in Canada, San Francisco is in the US, and New York is in the US. This assignment of cities to countries is an example of a function. More generally, a function is an assignment between elements of two sets that assigns to each element in the first set exactly one element in the second set. And the word set is a special term for a collection of objects. In the example above, the first set consisted of 6 cities, the second set consisted of 5 countries, and the function went from the first set to the second set. The elements of the first set, in our case, Paris, Tokyo, Toronto, Montreal, San Francisco, and New York, are called the inputs of the function. The elements of the second set that get hit by the function or that get produced by the function, in our case, Canada, France, Japan, and the US, are called the outputs of the function. Note that Poland is not an output of this function because no element from the first set got assigned to the country of Poland. The first set is usually called the domain of the function. The second set is usually called the codomain of the function. Note that Poland is part of the codomain, even though it is not an output of this function. In the first example, I denoted the function by using arrows. This picture is called a diagram. There are at least 3 other ways of representing functions besides diagrams. You can represent functions by using tables, formulas, and graphs. Let me give you an example of a function and I will represent it in 3 different ways. An example of a formula of a function is y equals 2x plus 1. This is a special type of a function called a linear function. The number right in front of x, in our case, the number 2, is called the slope of the linear function. The number by itself, the number without an x next to it, in our case number 1, is called the vertical intercept. Sometimes people call it the y-intercept. You can represent a few values of this function in a table. In the first column, you will have the inputs of the function. In the second column, you will have the outputs of the function. As inputs, you can use any numbers you wish. I will use -2, -1, 0, 1, and 2. To determine the outputs, you will plug in the inputs to the function. For example, if I use -2, then I will get 2 times -2, that gives me -4, plus 1, -3. If I plug in -1, I will get -1. Plug in 0 will give me 1. Plugging 1 will give me 3. Plugging 2 will give me 5. I can also draw a graph of this function. I know this is a linear function, which means I only need 2 points on its graph to draw it. Thankfully, I know more than 2 points. For example, the point 0, 1 is on the graph of the function. 0 represents the x-coordinate and 1 represents the y-coordinate. So I can find the point with x-coordinate 0, y-coordinate 1 on my graph. I add it to the graph of the function. It looks like a green dot. I also know that the point 1, 3 is on the graph of my function. So I find a point with the x-coordinate 1 and y-coordinate 3, and I add it to my graph. Since this is a linear function, now I connect the two dots with a straight line, and I obtain the graph of my function. I have two more exercises for us. In the first one, I want us to find a formula of a linear function going through 2 points, 1, 5 and 3, 11. If you would like to try to solve this problem on your own first, this will be a good time to stop the video. The general form of a linear function is y equals mx plus b, where m stands for the slope and b stands for the vertical intercept. To compute the slope, we compute the difference in the y values of the 2 points given and divide it by the difference in the x values of the 2 points given. The symbol right in front of y that looks like a triangle is called delta and stands for a change. So delta y means change in y. Delta x means change in x. The 2 points given are 1, 5 and 3, 11. So the change in the y values of the 2 points is 11 minus 5. The change in the x values of the 2 points is 3 minus 1. In the numerator, I get 6. In the denominator, I get 2. So I get that the slope of this linear function is 3. So the formula is y equals 3x plus b. Now what's left is to find b. Thankfully, I know 2 points on the graph of my function, 1, 5 and 3, 11. This means that the point 1, 5 satisfies this equation. This also means that the point 3, 11 satisfies this equation. I will choose one of those points, let's say 1, 5, and I will plug it into the equation and solve the equation for b. So now I plug in the point 1, 5. Instead of y, I use 5, and instead of x, I use 1. 3 times 1 is 3. I subtract 3 on both sides of this equation, and I get that 2 equals 2b. So the vertical intercept is 2, and the general formula for this linear function is y equals 3x plus 2. I have one more problem for us to try. I believe that there are a few functions whose graphs you should know. The functions are f of x equal to x squared, x to the third power, square root of x, absolute value of x, 1 over x, e to the power of x, natural log of x, sine of x, and cosine of x. If you would like to see how many of these graphs you remember, this will be a good time to stop the video. I believe that the function f of x equal to x is a straight line going through the origin, where the origin is the point 0, 0. That line forms a 45-degree angle with the x-axis. The function f of x equals x squared looks like the following. It goes through the origin. The function x to the third power looks like the following. Look how flat it becomes near the origin. The function square root of x shows up only on the right side of the y-axis, also starts at the origin. The function absolute value of x has a sharp corner at the origin. The function 1 over x consists of 2 pieces. This function is not defined at x equal to 0 because you cannot plug in 0 to this formula. The function e to the x looks like the following. It grows very rapidly on the right side of the y-axis. This function goes through the point 0, 1. The function natural log of x shows up only on the right side of the y-axis. It goes through the point 1, 0. The function e to the x and natural log of x, those two functions are related. We will talk about the relationship in a future video. Finally, the two famous trigonometric functions. The function sine of x starts at the origin and oscillates up and down around the x-axis, to the right and to the left. This function never goes above 1 and never goes below -1. The function cosine of x looks similar. It starts at the point 0, 1 and then oscillates up and down around the x-axis, to the right and to the left. This function never goes above 1 and never goes below -1.